Number 5. Okay, we'll see what we can do together. Okay, hopefully we'll be able to do the first few quick, right? All right. So looking at that one, I would probably rewrite it first, wouldn't you? Because it looks like it's got 2 inside functions. Okay. It might be one where we might want to default back to kind of what we did last year a little bit. Maybe. I'll tell you what, I'll do it with the shortcut. So you can kind of see what happens with the shortcut. Okay. How it would look. But whenever we see that squared on the trig, you want to add the extra parentheses and go to a squared on the outside. Okay. All right, so here's how I would do this with kind of our new BC version of the method. Okay. So y prime equals, what's my outermost function? Not x squared, but just squared. So I'm going to take the derivative of that, which was going to throw that to the front, right? So I'm going to go 2, and I'm going to write the inside the way it looks, right? I'm going to put the inside kind of towards the back, though. Sine of x squared. Okay. I'd probably put that way too far back. All right. Then my next inside function is this one, right? My next outermost function, my middle function is sine. What's the derivative of sine? Cosine, leave the inside of that alone, right? Now we're going to go to the inside of that one. What's the derivative of x squared? That's where I would probably write it there. Okay. I made it big enough so it filled the space, right? And the only thing I would probably do with it to simplify would be 4x sine of x squared cosine of x squared. And they could write it without all those parentheses. They could have the parentheses there. Is that one of our choices? First page, second page? Right above it? That one? Okay, 6. Okay. It looks like I need what rules on number 6 there? Product and chain. You know what my brain said, though? What did your brain say? My brain was in integral mode. What did it say? It said U substitution, because that's what I taught during 0 period today. So my brain said U substitution. It's not, right? It's product and chain. All right. So there's my red. There's my green. All right. You might want to rewrite your green as to the 1/2 power, right? Okay. So g prime of x equals. All right. What was the derivative of your red? 2. I'm going to leave my green alone. So x squared plus 7. Okay. What operation in between them? Addition. Good. And then we're going to leave the red alone. I got to do the derivative of the green, which is, I'm going to use the 1/2 power. So where's the 1/2 power going to go? In front. So times 1/2 x squared minus or plus 7 to the what power? Negative 1/2. All right. Good news is there's no denominator. Oh, but I got to deal with the chain rule. There's no denominator, but I haven't done the chain yet, right? I take the derivative of the inside. What's the derivative of the inside? 2x. Okay. Let's see what we can do to simplify. I'm guessing the simplifying is not pleasant on this one. I'm going to leave just this first part alone until I can get that back piece simplified. What happens with these 2's? Cancel. And then this thing I'm going to put downstairs and back under a radical symbol. Then it looks like I have an x and a 2x left upstairs, which would mean 2x squared. Now, knowing what multiple choice test writers do, they probably make a common denominator, because doesn't that sound like fun with a radical? Okay, so we're going to make a common denominator of the square root of x squared plus 7, which means this stays exactly the way it is, right? This one here, remember to make a common denominator to have to multiply both top and bottom by that denominator. Okay. So When I multiply it on the top, a radical times itself is what? The junk underneath, right? That's what Mrs. Ballard would say. Don't tell that to your college professors. Okay. All right, but look at what else I did. You got to be real careful because that's a parentheses. Because this is a distribute to, not a 2 times x squared only. Okay. And then the denominator just becomes the same denominator we had here. All right, we got to do some combining like terms. What am I going to do with the 2? Distribute. So I've got 2x squared plus 14 plus 2x squared over the square root of x squared plus 7, or 4x squared plus 14 over the square root of x squared plus 7. Is that one of our choices somewhere? Yeah? Bottom of the last page. I'm going to let everybody make sure they've got it, and then we'll go to the bottom of the last page. Okay, bottom of the last page is 7. Oh, there it is. That's number 7. We're up to number 7, right? Make sure I'm still counting correctly. Okay. I would probably rewrite that before I try to do that one. And I'm going to totally cheat, okay? Because I've got digital whiteout. So I'm going to do that. I'm going to switch it to this, which is the exact same thing, right? But I can very much see my inside function and my outside function now. Total cheating, right? Really bad habit. You really shouldn't do that. Okay. All right. What rules am I going to need? Chain rule and quotient rule. So we're going to, with the quotient rule kind of wins on this one, right? So I'm going to do quotient kind of as the first part. So red and green. Okay. All right. So, and they're saying it's dy dx. So I'm going to keep that notation. I'm not going to try to change the notation. I know it's subtract in here. I might as well write that. Derivative of cosine. Negative sine x. Good. And then I keep this denominator exactly the way it is. So I'm going to write it as sine x squared. Or if I wanted to write it as sine squared x, that's fine. All right. I'm going to keep the cosine the way it is. Cosine x. All right. Now I'm going to need that pesky chain rule, right? So what the outer function is what? The 2, the squared, right? So the outer function is going to be, oh, where's green? I'm going to bring out, I'm going to have 2. And I know I should have probably left I didn't plan it well. I didn't leave myself space in front. It's okay. We'll clean it up. 2, something to the first power. I leave the inside alone. Okay. I still haven't taken the derivative of the inside for the chain rule. What's the derivative of sine? Cosine x. And then I've got to do it all over the green. And what do I have to do to the green? Square. So sine x squared squared. I'm going to guess we don't have a pretty simplification on this one. All right. Let's see what we can do with it. So what's sine x times sine squared x? So yeah, so negative sine cubed x is what I would do with that. I hope they didn't bring out some weird trig identity back here. All right, I'm seeing 2 sine x cosine squared x. And then in the denominator, I'm seeing sine to the 4th x. I'm guessing we can probably get it just based on our denominator. Were they trickier than that? Is there another one? Are there 2 of them that have sine to the 4th x on the denominator? Or is there only one? Let's see. There's not even one? Oh my goodness. There isn't. What on earth have they done? Okay, so let's see what else has trig in it. That one has trig in it, but that's nowhere close. Oh, maybe this one. Maybe this one. Right? Those are possibilities right there. Probably not that one. I don't think this one. I bet it's this one here because there's a minus sign. Okay, so let's see if we can do that. I could take that denominator and do a common denominator. I can split up the fraction. Okay, so that's another little algebra trick they sometimes, if you have a monomial denominator, it goes under both. So negative sine cubed x over sine to the fourth x minus 2 sine x cosine squared x over sine to the fourth x. That's a cubed. I'm fixing the cubed. Okay, so this would be negative 1 over sine x. Everybody good with that? What's 1 over sine x? Yeah, so that's negative cosecant x. Is that close to that one that we thought it would be? Is that what the front of it is? Oh, let's see. I scrolled too fast. Where is it? Where is it? I put stars by them, didn't I? It's on the second page. Okay. Oh, it's this one. It's got to be that one, right? Okay, so I was wrong. Okay. I narrowed it down to the right two, though, probably. Okay, let's see what we can do with this here. And there's going to be some kind of greatest common factor come out. Did you see that in the answer? That they're going to factor out a cosecant x. All right. Here, what I would do with this, because I'm going to plan ahead. Okay. I see a fourth power. Because this is all multiplication, I'm going to split that fourth power up. Okay. So I'm going to split it up into 2 sine x I'm keeping the cosine squared. I already see one of the signs is going to cancel. So I'm going to do a sine x. I know cosine squared over sine squared is something. So I'm going to keep a sine squared. And I'm going to have another just plain sine x. So I took that fourth power one and I split it up. I tried to be really smart about it. Okay, I know I'm multiplying, so those two can cancel. Okay. I've got negative 2, and I'm going to rewrite it funny. 1 over sine x times cosine squared x over sine squared x. Okay, let's reduce this. So negative cosecant x minus 2. What's 1 over sine? Cosecant x. And what's cosine squared over sine squared? Cotangent squared x. Good. Now, that's probably more trig than they would probably do to you multiple choice. But you never know. All right, greatest common factor. Just cosecant? Negative cosecant x, and then this is going to be 1 minus 2 cotangent squared x. Is that the choice? Or is there still something else goofy? Don't tell me. They may have done a Pythagorean on us. Does it still not look right? Yeah, they did a Pythagorean. Isn't that nice? Okay, let's see. Oh no, it's not even a Pythagorean, is it? There's a 2 in there, isn't it? Oh my gosh. When the book comes out, let's see. It's another weird. It's probably a weird trig I didn't. I don't remember how much trig we did. I know at the very end we did. All right, so 1 minus 2 cotangent, but we've got a cotangent in there. Oh my goodness. Two. All right, I'm gonna have to think more on this one, so we're gonna stop there. I don't know what else to do with it. I gotta think about it. All right, I'll think about it while you all are working on your assignment today. Okay? And so we'll stop with 3 today.